my name's Jonathan. I like computers, and I'm super excited to talk about Rust for Beamers. I've been following Rust for a while, um, technically longer than I've followed Elixir for, which is interesting, and some other things in the Beam, which is really my loss if you think about it. But honestly, I just want to say, you know, I, Mike, thank you so much for having me, and all of you, thank you for attending this talk. There were couches with your name on it that you could have been on, and instead you're here, and I love that. Um, so, yeah. So who is this guy? I'm a computer scientist. I did about 5 years in startups and going on my 10th or 11th year of healthcare. My major areas of inquiry are really just distributed systems, security and compliance automation, and programming languages in one form or another. For those of you who are, apparently this is a thing, my Patronus is a panda holding a glass of scotch. Um, yeah, and if you want to like see more of my work and stuff, you can, I mean, I'm pretty consistently uncletron.com, but again, just, do your thing. So here's some goals for this talk. We want to compare and contrast the Beam with Rust, its syntax and semantics, its approach, etc. We'll write some code together, and I really want to start a conversation. So first of all, please throw questions in the group chat to everyone so that we can all see them, right? And also, so like you can queue them there. I have it up, but also there will be semi-regular pauses for questions throughout, with some crappy puns. So stay tuned for dad jokes. Non-goals for this talk are to be exhaustive in any way. That's not a goal here, right? So I really want to get the juices flowing and see where it goes from there. I'm thrilled you all came. Glad we have a small group. Makes it easier to interrupt me. So, all that, right? Cool. So an open secret is that Lisp is my mother tongue. I don't know if anyone remembers Lisp, but yeah, so I wrote my first program in, I think, first grade, and I tell junior engineers and people early, that someday I might even be good at it, but today's not the day. So like, let's everyone calm down, right? But also, I like Elixir because I think that there's a lot of really interesting things happening in this space. So, I think that we should start with, it stands to reason, a common understanding of the Beam, right? And the reason is because I want to get definitions on the table for a few reasons. One, so that we're all on the same page, but also so that we can sort of begin this compare and contrasting of, semantics and sort of the philosophy and approach and so on and so forth. So a common understanding of the Beam, right? And it's this low-level platform or kernel. By the way, the conceptualization of the Beam as kernel is borrowed shamelessly and gratefully from the OTP at a high level chapter of Adopting Erlang. You should definitely read it. So the Beam is sort of provided as part of the Erlang runtime system, and it provides goodies such as the actual kernel library, standard library, crypto SSL, and it ships and combines with OTP, which you can learn lots more about by reading the Beam book. We're gonna try to make these slides available. All the links should be clickable, so like please dive deep on anything you want, and definitely keep in touch. So I was a Rails developer for a while because it paid the bills. Ruby has some interesting things going on, like the small talk Lisp love child sort of. And then for Ruby, Rails was really the killer app. And it's my personal belief that Phoenix, in certain ways superior to Rails, is not, it's my personal belief that it's not actually Elixir's killer app. And the reason for that is because OTP is killer's app. Sorry, OTP is Elixir's killer app, right? And I'm saying that because I make a lot of mistakes. So like, I'm glad that I can have the takes a lick and keeps on ticking foundation of OTP there. And you can we're now at this point where we have many languages that run on the Beam, Erlang, Elixir. There's Lisp flavored Erlang, Gleam. I saw just went 1.0. Congratulations to that whole team. I know they've been working their butts off. It's really exciting. Other things as well. We're going to focus primarily on Elixir. So we now break for any questions you have real quick. What questions do you have so far? Just so we're all on the same page.
I guess it might be interesting so I think 90% of the people here having a look are all heavy Elixir devs, right? So yeah, I think we should all be on a relatively similar, other than myself, obviously, on a relatively similar page. But
dirty like that.
All
Right.
good.
Well,
All good.
any additional questions or commentary, again, throw them in the chat. No problem. So what about Rust, right? And I'm like, oh yeah, Rust, right? And how many of you are familiar at all with Rust? And I'm asking, if you can just give a thumbs up in the chat, or I can't see everybody, unfortunately. Yeah, a little bit. Okay, cool. So I think Rust is really interesting. I think it's actually really interesting in combination with the Beam as well, because now we're at a point where you can write natively implemented functions, NIFs, in Rust and call them from Beam languages like Elixir. There's ways to make that bridge really easy, and I think that's pretty cool. So here, some people seem to think about Rust, Rust was designed as a successor language for C and C++ devs. It's somehow a direct competitor to languages like Go, and Rust is really hard to learn. So let's tackle these one by one. So misconception 0 is Rust was designed as a successor language for C and C++ devs, right? The real story is that, yeah, syntactically, Rust does have curly braces. Fine, sure, okay, syntactically. But semantically, Rust descends from the ML family of languages, including standard ML, OCaml, and Haskell, much more than it descends from any of the, let's say, first, second, and third generation of systems programming languages. And again, systems programming languages is in quotes. If you do want an actual language that is genuinely designed to be a successor to C and C++, I would look at Google's Carbon project, which is, I don't know if there's still activity, but that's a really good example of something like that. And the truth is that all comes from the type system, because Rust's type system is designed to promote correctness in both functionality and memory management. So I would say that, if anything, the entire newer generation of systems languages, which we're going to talk about, their response to issues arising from memory and safety more generally, right? So I don't actually think that, Rust is a reaction to that any more than Go, Swift, Zig, Nim. I mean, the list goes on. Misconception 1, it is a direct competitor to languages like Go. What is a language competitor, right? And what kind of losers running these competitions, right? Like, I just wanted to know, who are the people who have nothing better to do? Like, it can't just be me, right? So anyway, I just wanted to know, I wanted to understand that. Each of these languages, and I mentioned a few of them verbally earlier, they all aim for different spaces. So Go is there to solve Google's problems, and there's a limited amount of community input that they take. Swift is specifically Apple's response to Objective-C as a main development language on macOS, iOS, and friends. I guess Zig is shooting for the sort of fine-grained memory allocation and management, because you basically have to pass an allocator everywhere. So there's some interesting things there. This one we can just debunk. Rust is really hard to learn. Google totally debunked this at scale, right? Along with clarifying other realities of Rust adoption. Great article. It has just enough of an object-like experience that many feel comfortable almost immediately. And if you know any other functional programming languages, Rust is nothing. So this brings us to a question, which is, what exactly constitutes a functional language? All right. Does anyone have a definition that they want to venture is good enough for what constitutes a functional language? Like, please help me out.
Yeah, I just want to comment on this point. May I?
Please. I would
Yeah,
encourage it.
so I think that maybe Rust is not difficult and it's hard to learn on itself, syntax wise. But the thing that makes it hard is that it allows you to do stuff that is inherently hard. Like when you're tackling problems that you wouldn't be on other programming languages, like multi-thread access to the same entity and stuff like that. Things that, for example, you cannot do in Erlang. So that's I guess John Armstrong said that, like, if you want to make something very easy to do, you just eliminate the problem, like make it impossible to do. So it's not a problem. But in Rust, you kind of have to think about, how do you do this, which is a difficult thing to do. So then you have to implement like a fucking I'm sorry for the curse word.
No, don't worry. You should hear my Yiddish. It's okay. Please continue.
You have to do the arc vec.
Yeah, right.
Thing, blah blah blah. So in order to allow those things. So it's not, maybe Rust isn't hard to do in itself, but if you have to do hard stuff with it, then it's gonna be hard.
Right. I'd rather have Rust there, helping me. Yeah, I totally agree. And I mean, look, we've all done the, I mean, if you haven't, I've done the C and C++ route, and I consider myself an okay programmer. Like I said, I know people who were way better than me in C++, and they still produce memory safety bugs like everywhere, right? So like I think that there's a lot of safety netting, and I have an analogy that is, I sort of link the Rust compiler to my Subaru Outback, later in the talk. But Pedro, I think that's a great, yeah, if you're solving hard problems, then there will be a proportional scale up in complexity for the tool you use to solve that. Is that fair, Pedro?
Yeah, that's what I meant.
Okay, good. So yeah. So I mean, I think that's a really great point. So does anyone have a definition for what constitutes a functional language? Because we sort of throw around functional programming. Does anyone have a definition that's good enough, or they want to venture a definition? Like, please go ahead and be wrong. It's my signature move, right?
Say it's a language that has first-class functions that you can compose and use to evaluate to build up the program you're building, something like that. I mean, I don't know. I think that's kind of at its core. It's got functions in it, and you build them and compose them and pass them around and execute them.
So, Alex, turns out that there's a big name who agrees with you, Martin Odersky, who is known in smaller rooms as the creator of Pizza and generic Java. He was the original implementer of Java generics. Apparently, he did it in like 6 weeks, fueled by coffee and cigarettes. I don't know if that's true or not, but that's like the legend that's handed down, so I'm going to go with it. He's also the creator of Scala. And Odersky, right there with you, Alex, he has some insights for us. So he has what I'll call a dual definition of functional programming. One is what he has said is the bold thesis, which is that a language is functional if it disallows mutable state. And there are certain pieces of that are really interesting and really just really impactful depending on the language. So that's his bold thesis. He also has the weak thesis, which is that a language is functional if, and here's where I'm with you, Alex, right? If it has higher order functions. So if it lets you treat functions as first-class values, accept them as function arguments, return them as a return value from a function, or that rather in the Lisp world, we would say that a function evaluates to a value, and that value is a function. Cool, right? And I think that's great, right? I mean, and is the weak thesis not good enough, right? Like, is Alex's thesis not good enough that, yeah, it's functional if it has higher order functions? So yeah, come on, I think it is, right? And getting down to it, my opinion is that this whole definition or categorization of functional is secondary to, a language's expressiveness and inherent utility, which actually goes very closely back to Pedro. What you were saying is that, for hard problems, certain programming paradigms are more suited than others. And that's sort of my opinion. Furthermore, my Uber driver's response was, why did you sit in the front? And that one I don't have a good answer to, but now that Uber driver knows a lot more about functional programming.
You did warn us. You did warn us.
It was a long ride, Mike. I don't know what to tell you. It was a long, I mean, for me, it was short. It was very interesting. Anyway, so now we're going to pause for your questions. What questions do you have so far? Because I really want to get to the live coding, because this is where I think we're going to have the most dialogue, and I'm excited about it. What questions do you have? Cool. Love you all. I'm glad you're here. All right. So, who's ready to look at some code? Oh, finally, he'll stop. So
I'll have some more questions once I learn more about Rust from you.
Do it. Talk to me. Go ahead.
So show us some Rust, and I'll have some questions.
All right.
Your mistake was saying that the good parts is coming out.
Yeah, the good parts. Yeah, So we're gonna write. This is sort of what the struct would look like in Elixir. We're going to call it a data chunk. It's just abstract. Again, our intention is not to be exhaustive. It's to show stuff off, right? So here, just so we see, a little module doc, it's just a chunk of binary data where I have a struct with contents, path, and size. And then here you can see that the type signature is that contents is a list of bytes. The path is just a string and the size is just a non-negative integer. So it could be 0 or, could be anything above that. So let's see how this could look in Rust. All right, so let's, so I'm gonna, is this font big enough for everyone, by the way, just so I can, because I'm gonna open VS Code and everything. I mean, I'm actually an Emacs guy because I Lisp, but everyone uses VS Code now and I don't want to get laughed at because I have like so many feelings. Okay, so we're gonna do, yeah, so we'll do cargo new, we're gonna do lib, and we're gonna call it, data chunk, right? Okay, and this should be pretty familiar from the mix world, right? So let's look at what we have so far. The first thing we have is this cargo.toml, which has a little bit of info in it, right? This is just sort of metadata file. This is more or less equivalent to the mix.exs file that you would see there. I'll do cargo add. Yeah, so dev, I'll just add pretty assertions in case we want to test. And now when I look at cargo.toml, you'll see that there's dev dependency called pretty assertions there, and we're good to go. So, let's open up code here. This is going to have to be bigger. And let's take a look at main. Is that big enough?
Yeah, I like that.
That's okay. All right. Yeah. Because there's nothing worse than when you can't see that, So, yeah. All right. So here you can see that there's a pub. So the fundamental unit of Rust software distribution is called a crate. And crates can contain binaries or multiple binaries or library entrance points or whatever you want. So this is saying there's a pub function, right? And here you can see that there's add, it's taking 2 usize, right? It unsigned integer types that are as big as the processor, right? And it returns a usize, and then here's some tests. So we're gonna blow this away in a second, but I'm just gonna create a new file here that's gonna be called data, right? Chunk. And just the module system in Elixir is really nice because the compiler and every sort of mix sort of picks up all the EX files. We need to actually tell. So here we'll say that's going to be pub mod data chunk, right? So that we know it's there. So let's go back to our definition here, right? So we know we need a struct, right? And it needs to have these types. So let's give this a shot. Okay. So we're going to come here and we're going to do, struct data chunk, right? And we're going to give it some fields. So this will feel a little more C-ish and C++-ish and Dart-ish and other things where you're sort of defining the data type separately. I'm going to show you why that's important. If you're familiar with protocols in Elixir, tell me when you go, oh, cool, because there's some neat stuff coming here, okay? So the first thing we're going to do is we're going to say that, this is going to have contents, right? So we're going to do we're going to do contents, right? And that's going to be a vector of unsigned bytes. Okay. By the way, before I save this, I just wanted to do Rust. Oops, I can totally type Rust format. Yeah. And I'm going to set just for all you kids, I'm going to set the tab indent to 2. If you don't like it, you can go elsewhere. There's lots of other things in your life. All right, good. Blessings, right? So yeah. So by the way, set lines that end in a semicolon, except it's when it's part of a definition, right? So we have contents that are there. We'll have the path, right? Which is going to be a path buffer. Okay. And if you think strings are weird in Elixir and Beam languages with like binary versus actual string, just wait, you're going to have a blast. Because in Rust, a lot of types differentiate between whether they're on the stack versus the heap. And that's really cool. Also, a fun thing is that Rust has no garbage collector. All memory management is done at compile time. So if the Rust compiler cannot infer the size of your data type, it will not compile. It's actually a compiler error. So you will never have, if you ever have a memory issue in production, it's because there's a problem with the Rust compiler that it let that compile that it shouldn't have compiled, or it just compiled it wrong. Okay. Then we're going to have size, which is going to be no, it can be usize, right? Because it can be non-zero, right? So there we go. There we have kind of our side by side, right? So is everyone following this so far? Because I want to talk about what we can do, right? Okay. So then what we need to do is if we want to have functions that are attached to it or associated with this under the same logical namespace. And again, I truly think that, and it's not the only way to do it, but one of the best influences of object-oriented programming has been underlining the importance of associating behavior and data with one another. Related, we can talk about that whenever you want, but not here. So in order to do that, you want to implement some, right? You want to implement some functions, okay? So what we're going to do is we're just going to create a constructor, right? And this constructor is going to basically be this, right? Now, you will notice a few things. Actually, wait. So I can do, this is a naive implementation, which is fine. Oops, sys usize, right? And this will returns a struct of type self, right? So this is what it returns. So this is sort of a constructor, much in the same way that you would need to do a new function on an Elixir struct, right? So you would sort of want to have a new there. And then there can be variations of it, which can be new from path, new from blah, 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 like whatever we want to do, right? So in this case, you have this nice, you can do contents, path, size, and you're done, right? So that's it kind of does that nice piece with structuring and destructuring based on things. So now let's just talk about something, all right? So this is an associated function. And the reason it's an associated function is because you would need to call it like this, right? Data chunk new, right? Blah. It's not considered, I'm going to use the term method, but there are a lot of people who have said Rust is functional, or it's not object-oriented, or it is one or the other, and they're very loud. So I'm going to defer to them because, hey, who knows? But let's just say that we're going to do a method for now, right? And the convention is you want to have a len method, right? And that's for computing the length. So we're going to say, len, and this is going to take self, okay? Now hold on. A lot's going on here, right? Right? A lot's going on here. First, you can see that the return type, which is similar to what would be a type spec in Elixir, right? The return type comes after the arrow. The other thing to know is that much of Rust's usage is type inference. You get type inference very, very nicely, but it doesn't use full what's called HM type inference or Hindley-Milner type inference, because you still have to type function boundaries, which should be very natural to Elixir because that's pretty much the only place you can type things right now anyway, okay? So, here we can just do, right, self.size, right? And the reason that this is important is because of this ampersand. So let's take a second, and I want to talk about some of the differences that we have here. One second, let me view slideshow. Okay, so I'm just going to just jump back to this for a second. Okay, so key point: all of Rust's coolness comes from its type system. All right, pretty much all of it. So this is a chart that I made because, whatever, of language and its mechanism of coolness, right? So C, it's cool because there are no rules. And C++ is cool because everyone pretends there are rules, but there still aren't. C# basically has .NET and the CLR, which lets you do really interesting things with language interoperability and certain compiler optimizations. Java is not cool, but any coolness comes from the JVM. Kotlin, the type system in the JVM, because the JVM is like one of the 7 wonders of the software world. Lisp, basically metaprogramming because of eval and apply. OCaml, type system. Ruby, metaprogramming. Rust, type system. Scala, type system / the JVM there again. And TypeScript is also the type system, okay? So what do I mean when I say this? So Rust has a specific type of typing called affine types. And that comes from this is a flavor of substructural typing, which comes from the substructural logic. And it basically says, what does an affine type say? It says you may use a variable at most once. And that sounds a lot like a pain in the ass. let me tell you something. I've been saved by this so many times, and then I'll go to another language like Python or even Elixir, and I'm like, wow, they just let you do it. They just let you reuse things, right? Like you can like double pay a bill or anything because you can just do bill.pay twice, right? And I'm like, it's amazing. Okay, so you
So
can
this
use
is just like Erlang then.
Specify. Sorry, can you
Yeah,
specify?
Well, Erlang, you
let
can
me add to
only.
his question. So, excuse me if I'm being rude, but let me add to his question. By use, do you mean assign to or call?
I mean, use the value of that variable binding, right? So you can use a piece
Okay,
of
so it's
data
not
at most
assignment,
points.
it's usage. Okay.
Right. Now, Rust is immutable by default, which is nice because, you have to say, hey, let mute, right? So you contain mutability, which we all know is a source of bugs. And by the way, this sort of very supervised sharing of data between things is really important. The reason is because there's another thing that I'm not going to go into as much called the lifetime system, which is how Rust does compile time memory management. It says, wow, you are like, here, you ready? In C, you want to return a string. They say you have to invent civilization, right? Okay, I return a string from a C function. Whose responsibility is it to clear the memory? Well, it can't be the producer of it because that function just ended. That function just exited and returned a value. So it's got to be like, whose responsibility is it to actually, okay, so all that stuff is really well supervised with lifetimes, and also shared mutable state becomes impossible in most cases. And the reason for that is because of the borrow checker and borrowing. So I'll talk a little bit about that. I just want to finish with substructural typing because I hope I'm going to answer your questions. You can compare and contrast linear types, which is from predictably the linear logic, which is you must use each variable exactly once. And there are extensions, there's like linear Haskell and linear, Idris and whatever, where like if you instantiate a variable, you have a piece of data, you have to use it. And there are reasons for that as well. The reason that I'm bringing this up is because as we all know, there's been some amazing work done on Elixir's type system. And the reason that's cool is because they're sort of talking about non-traditional or like non-mainstream ideas in type theory are getting some application, including the set intersection types that that wonderful PhD student had worked out with the strong arrows and everything. And I'm really excited to see where that goes. Okay, so important thing, Rust type system is tied to its memory model. This means that memory problems become compile time errors. Okay, this is a big difference from Elixir and the world of the beam. The world of the beam says, you know what? You can't prevent failure. We're going to let it crash, right? And we're going to have really good isolation between processes or actors, right? With message passing. So you can't really share state either way. But that's sort of done at the runtime. With Rust, they try to figure out everything they can ahead of the compiler, okay? Sort of ahead of time. And there are really good pros and cons to that. In both Rust and Elixir, I can very easily get stuff past the type checker, right? Like, no, I'll show you. I can do it really interestingly. Like, I'll show you some really cool stuff you can do. I mean, it cool/evil, like only you would know, right? But yeah, so basically, if it compiles, you can have really good confidence in its memory management capabilities. On older hardware years ago, I once did a benchmark. I could do multi-gigabyte CSV files with a Rust binary that never used more than 5 megabytes of memory at a time. Because it's all, and again, that's all compile time, no garbage collection pauses or anything. So I have explained it thusly, right? With an obligatory garbage car metaphor, because what would programming discussions be without a car metaphor? So I drive, right, a 2018 Subaru Outback, okay? I'm very proud of it. My wife has a Tesla. She's way cooler than me. God bless. I married up. It has this thing called the eyesight safety package, which has got like binocular vision and sensors, and it like senses lane change and if you don't brake soon enough, right? And most of the time, I just completely forget about it. I do. I completely forget that it's there until I'm about to make a mistake and it stops me. And then I'm like, whoa, thanks, Subaru Outback eyesight. You really saved my butt there. I really appreciate it. And yeah, it's not perfect. Occasionally there will be like a plastic bag that the wind blows across the highway and it'll be like car. And I'm like, no, it says thank you. It's just a takeaway bag, right? And so while it's not perfect, I'm still really glad that I have it, right? And I think of the Rust compiler like the Subaru's eyesight, only with, again, complexity scaled up proportionally. So Pedro, you set us up for a win here, right? I really appreciate that. So the Rust compiler, yeah, it does tons to help me, right? I mean, I like everyone else produce bugs. I mean, maybe Knuth didn't produce bugs, but I do. Okay. So most of the time I completely forget about all the helpful work the compiler does until I'm about to make a mistake and it stops me. And while it's not perfect, sometimes what I know that I'm trying to do is probably fine, right? It stops me. And so I'm still really glad that I have it either way, right? So do you sort of see where I'm going with this, how I related the two? I tried to do it. If you've never driven before, this makes no sense, and I'm so sorry. I should have asked if everyone has a license before I started this. I'm not a clever man. Okay, so yeah, all right. So let's come back here. By the way, I just wanted to show you here. Let's just do a function. We're going to call it reverse, right? And it's going to take an S, which is going to be a string, right? And it's going to return a string. Okay. This type checks. Okay, it's the identity function, bruh, right? This, okay, so this is a problem, right? This type checks. As far as the type checker is concerned, yeah, it takes a string and returns a string, no problem. It happens to be the identity function for strings, but it type checks. So you really need runtime protections and you need ahead of time things. I mean, all of these things combined to help you reduce classes of bugs, and Rust's approach is much less do it at runtime and much more make illegal states unrepresentable. And obviously there's a natural, I'm not making a pun here because of the Elixir type work, but there's a natural intersection where these things sort of like super linearly emphasize and help themselves, right? So let's go and let's add a, you know what? I'm going to do a constructor here, right? And I'm going to do pub fn, and it's going to be new from path. Okay. And this will just be, right? And this, but here's the problem, right? In Elixir, we have bang methods. And what is a bang function? What does a bang function mean? It means that what? If a function has a bang at the end of its name, what does that mean?
You're going to mutate the state.
Yeah, but also, which is another way of saying it could fail, right? Like it can throw an error, right? So it's a fallible computation, right? That is just convention. There's nothing that the Elixir compiler or the Beam does to make that enforced in any way. What Rust does is it uses a special type called a result, right? Which has the signature TE, which says if it succeeds, return a T. If it fails, return an E. And this is similar to when you sort of case or without an error tuple. If the first thing is the atom okay, then you get the value you wanted. It's sort of equivalent to that, but they're really interesting language niceties for helping with that. So I'm going to talk about this. So in this case, you know, if it succeeds, it's going to return self. If it fails, I'm just going to say it's going to return a string saying this is what went wrong. Okay. Okay. So the first thing I want to do is I'm going to come up here and I'm going to say, you know, here, let's do this. So I'll say use std fs, right? Which is really nice. So then I can say, you know, let contents, right? I don't know, equals, here we'll do fs read, right? Which by the way, returns a, it returns, as you can see, it returns a vector of U8 or an error. Okay, so ordinarily in the Elixir world, we'd have to case this out. We'd have to match this, right, or case this out to see which one it did. You can do that, and the way you would do that is this: you would say, "Oh, well, Freudian typo, math instead of match," right? So here, so you would say, okay, so if it's okay, right? If it's okay, then we get the bytes, right? In which case, we can just sort of return the bytes, right? And if it's an error reason, right, we can return format. You know, by the way, bang functions and calls in Rust mean that they're using a certain type of macro, right? So they're macro calls, and those are done at compile time, just like every other macro system that's worth its salt, right? Rust has two types of macros. They have a syntactic macro, which is Lispier, and then they have a procedural macro, which is more racket-ier, schemier, sort of. If you're interested in those things, there's some cool stuff, you know. So here I can do error, reading, right? And I can do here, let's do error reading that. And this will be, so the first thing will be, the path. And the second thing will be, I'll just do reason to string and we'll be good, right? Oh, wait, but there's a problem. What is it? Okay, so the first thing is that this basically returns a string. So now we have incompatible arms, right? So the okay thing returns a vector of bytes. This thing returns a string with an error here, right? So to sort of, and this should look very familiar to you if you've ever done like nested cases and all this other stuff. So yeah, we can totally do that. But instead of doing that, right, I just want to clarify, instead of doing that, we can actually just do this, which basically says this, oh, right, sorry. So because it's IO, it's the unit type. I'm sorry?
I think you're returning a void because you have the colon there.
Yeah, there we go. Right. So this is the unit type, which is obviously not working. But what does this say? What is the question mark operator? That's called the try operator. And what that means is if it returns okay, unwrap the value. If it doesn't, return a result early to the caller. Right? So it's basically like a short circuit without the confusion of multiple return statements and like early returns and stuff like that. And it's all the time checked by the compiler, right? So now, we can say let size, right? Will just be contents.len, right?
So then it would return the unit if it fails.
Yeah. So the reason for that is because I'm not doing anything to coerce the error types into compatibility stuff. So because read, if you see the return is an IO result, and an IO result is basically a result where yeah, I mean, I can actually show you. I don't know why I'm hesitating. I set myself up specifically for this. So here, so I'll do IO result here. So this is right where it has its own error type there, right? Where it returns IO error. And this is where it gets complicated. I want to do a call out to Jane Lusby, who is the author of the error crate color error, and she has been instrumental in getting the error traits and things like that handled really well in Rust to make these problems, these little warts go away, right? So now I can do do self, right? And this can be contents, path, size, right? And then I can return the variant data chunk, and we should be good, except this still doesn't work, right? So in this case, I'm just gonna switch it to be std IO error, right? And path doesn't work here. Okay, so now why do we have this, right? Let's find out. Let's find out why we have this. Let's look at a compiler error. So we're gonna do cargo build. Okay, value here used after move. Remember when I said it has affine types? It means you can use it at most once. But there's some rules here that the compiler lets you go. One, you can borrow it any number of times as long as it is an immutable borrow. If you mutably borrow it, you can only do that once. Think about that, because that tells you a lot, right? So it's like only one person can, again, the ownership and borrow checker, right? Only one piece of code can own any piece of data at once. And you can give out an infinite number of immutable borrows, just borrow, right? With the ampersand operator. But if you try to mutate it, you can only have one, because imagine if I were reading from the critical section that you were writing to, right? I had but it doesn't work, right? So you can have, and by the way, they're much more thorough and intuitive write-ups than the one I'm giving you here, okay? So the first thing we can do is we can just make this really easy. We can just pass it a borrowed thing, because read takes any P, which implements the asref to path trait, which is really cool. So it basically says anything it knows how to turn into a path, you can pass it, which is a nice little thing you can do, okay? So now this type checks, right? So the first thing we do is we read it, right? Then if that succeeds, we continue on. If not, it escalates to the calling function, right? And by the way, if you have an unused result, you get a compiler warning.
So
Why?
quick
You get a compiler.
question when
Yeah,
you say
please, go ahead.
use.
Yeah.
So do you mean use within a limited boundary like a function? Or because I noticed that you called out how path is passed in, and then you had to use the ampersand to get around that. But inside this function, you created contents and then you used it twice, once to get its length and then once to return it.
I am so glad you asked. Let me tell you why. Because len is typically defined to borrow self.
Ah, okay.
And the reason I wrote this before we went on the tangent, I told you that to tell you this, right? Which is that you can have methods that consume the data that they're working on, which is really nice. And I'll tell you, like let's just remember, right? Struct, I don't know, I'm gonna do bill, right? Amount is gonna be use size, because it's gonna be in pennies, right? Bill, right? In other languages, you basically have, right, more or less pay, and then it would be result, use size or string, right? Like, or whatever error type you're using, right? And then you can call pay, because this borrows, you can call pay as many times as you want. So you can double, triple, quadruple, or do it in a loop. Hang yourself at high speed, right? Like, and normally that's reserved for using Kafka, right? Enough rope to hang yourself with, but now you can do it at scale. So this is really cool. But if you get rid of that ampersand, you're basically saying, all right, calling this method uses up the bill. There is no bill struct in memory anymore after that. It gets deallocated, and any calls to it would not be a use after free. It would not be a double pointer dereferencer, whatever. It would be a compiler error. So you would not be able to compile code that double pays a bill so long as you do this, right? And there are ways to, add checks and all kinds of things that are really cool. And in this way, it's a very attractive way to sort of, as I said, make error states unrepresentable. Okay. And that's a big deal. So what I just told you, I told you a lot there, only to write a length method, right? Which is really cool. So other things we could have done. You see this a lot in newer people who are fighting the borrow checker. You spend about 2 weeks fighting the borrow checker until you realize that it's just there to stop you from crashing. And then you're like, oh, thanks, bruh. Right. And you sort of like forget it. And then again, by the way, it's wild when you go to TypeScript or whatever, and they let you do it. And you're like, I should not be able to do, like, someone wrote a really good piece. They're a professional Python programmer, about how Rust has influenced the way that they write Python. And for me, it was fascinating because I'm a language nerd and I'm really interested in quality and reliability and all these other things. And that's really, it's really interesting to me because, again, my bread and butter is distributed systems. And the reason that that's relevant is because I'm doing some research with Drexel right now about, and you can ask me about this after, about basically distributed systems correctness, but security correctness, because we focus so much on functional correctness that we often forget that, like, even having a proof that it's okay is nothing, because an attacker will, compromise a node and suddenly your assumptions are garbage, right? So, like, you need sort of both ahead of time and runtime, which is why I'm giving this talk, right? Because this is like right up the alley, philosophically. So I can speak about, as a practitioner, times I've gotten my butt kicked and things that have helped me, right? So yeah. So when people fight the borrow checker, one thing they'll do is they'll clone it. So they just basically, they did like, actually what it says, they just created a new path buff and got rid of it so that this one wasn't consumed, because this obviously cloned the signature borrows self, right? Yeah. Cool, right? So, that's one way they'll do it. There are lots of other, I've seen people who don't know what they're, and when I say, by the way, I just want to be really clear. When I say I've seen people, I mean me. I have done this stupid thing where I've been like, path string is, I'll format, here, and that'll be path.display, right? So now I'm, making a string that I can pass in, here, because, like, I didn't know what I was doing, and I didn't understand how the memory model worked, and I was like coming up with all these weird hacky ways to do it, right? So because read takes anything that it knows how to turn into a path, right? You can do that kind of weirdness. Yeah, let's undo that before we get too far down the road.
Question, could you have just sent in path
please.
as an address?
No, because although they are locations in memory, this is a really good question. There are pointers in the form of references, but there are smart pointers also elsewhere in the language, but there is no pointer arithmetic. Okay, checked or unchecked. So that's really nice because you can send in, a reference to it, which is essentially, which is semantically similar to a pointer, but you can't like add 5 to it to get an offset and only pick out the value you want. Like that crap doesn't fly, right? And the reason I know that is because I've done horrible things like that, right? Like, I mean, we've all, anyone who's worked with C and C++ has done that. And so again, with the result types, those are annotated must use. So if you don't use the result type, the compiler gives you a warning, hey, you should really use this, right? Which is really nice. So a couple small things that I think you might like, triple / comments or doc comments, right? So we can constructor, right? Here, actually, you know what I'll do? Here, I'll do abstract or general constructor for values, right? And then, here I'll do constructor from a file path on disk, right? And then when you come here and you do cargo doc, right? It'll like do that, and then you can here. So I'll do open cargo targeter doc data chunk index, right? Oh, sorry, it opened in the wrong window. Here you go. Right. So like now, now you can see this, and when you go into data chunk, you can see, oh, yeah. I mean, it all depends on being public and everything like that. So I apologize, but like it's got really good tooling for that. You can have doc tests. Tests are really easy to do. I love that also. So here, so I could do pub, right? I could make a pub struct and then it would work. It's got really nice privacy. You can have pub in crate, right? So you can say it's only public within the boundaries of this crate. So I can use it everywhere, but no one else can, which is cool if you're distributing libraries or, you have like internal stuff that you want to kind of keep there. And by the way, there's no reason you need to do impl. Like you could easily just create a function that says, that's len that takes a data chunk of type data chunk and returns, right, usize, right? And then you can just do contents.len, right? Well, which, yeah, right. Like, so you can sort of see that. And it's okay to take the data chunk here because, yeah, I mean, so there's some interesting experiments you can do, like try calling this and see if you need to actually say, well, you can pass a reference to one or not, right? So, that's cool. Last thing I want to do real quick is, because we're getting to the end of time and I want to, we're getting to the end of time. I'm just going to show you tests. So we're going to create a module behind a gate that's called tests. And we're going to say use super, right? And we're going to annotate, this one as, test new from path works. I'm just going to show you this, right? And it just to show you. So at this point, I can also do use pretty assertions, assert equal, right? So new from path works, right? So we're going to do let data chunk, right, equals data chunk new from path. And I don't know, now we got to create a path. So we'll do let file path, file path equal, we'll do path buff. Well, here, you know what, we can actually just do path new, and we can pass it a string slice. And we'll say, I don't know, cargo.toml, right, to path buff, right? So now we have an unowned path buff as opposed to a slice. And then we can just give this file path, right? But now we have a problem, right? So which is that new from path might fail. right? It's a fallible computation, which we know because we are returning a result. Just like other things may return nothing, in which case they return an option, right? Which can be either, it can be either some or none. So there's no null, and it's sort of, it's like slightly more annoying. It forces you to deal with it, but you have to deal with it. You have to be intentional about how you handle missing values. You have to be intentional about how you do that, which is nice because then the compiler is helping you. So in this case, we can't do, because we're not returning a result, and unit test functions can't do that. So the naive thing would be to do unwrap, right? Which basically says, give me the value or panic, right? And a panic is not something you can really recover from, right? You should really only be panicking if there's an unrecoverable error, right? An unrecoverable error. So I don't like to do that. I don't like to use unwrap anyway. So I like to use expect because, error reading file in test, right? This way, if it coughs and dies, it pukes everywhere. It does so because, it does so with the error message, right? Which is really nice. So, now I have this data chunk, and I'll do assert ec, right? And I'll do, I don't know, data chunk dot, I don't know, len, right? And I'll say it's going to equal, I don't know, 1,024 bytes, because I want to see a failure, right? Like I want to see a failure. So now I can do cargo test. Wait for it. Okay, fail, right? So and by the way, this is what pretty assertion gives you nice diffs like you're used to, right? So 227, 1024. So now I'm going to be an idiot and I'm going to change it to 227 so it passes, right? Cool, right? So it works and new from path works, right? Now, I don't know about you, but I make typos. So we're going to load cargo.tumk instead of cargo.toml. Right. So it panicked, right? And it says error reading file and test, OS code 2, kind not found, message no such file or directory, right? So that's really nice because, that's not the kind of thing you can really recover from. Like, I think that we have this sort of, romanticism about error. And I'm just speaking off the cuff here. It's nothing to do with Rust in particular, but like, I think we have this sort of romanticism about catching exceptions and things and being able to be like, oh yeah, I know how to do. And this is coming from Lisp, which has a condition system, which generalizes exceptions. We sort of have this like romanticism, like, we could, the caller can figure out the problem and tell you how to continue, but that's really not always true. And in fact, I found that it's rarely true. So, at least you have this way, which is not an excuse for exceptions as flow control or anything like that. Because
one thing I've enjoyed about using Rust is the fact that I can put my tests directly in the file itself. That's been nice very helpful.
Yeah, I was gonna ask about that.
Please.
What do you
ask?
How do you feel about this thing? Like, I mean, files structurally. I mean, putting tests directly in the module versus like putting tests in the test folder.
You don't have to. You can have a test folder too, right? You can have typically the idiom that I see, and not exclusively idiom, is that unit testing things, whether you're testing really one component, whether it be a struct and its implementations or something like that. And I didn't even get into traits, which I was hoping to get into, but I don't want to take too much time. And then people will put integration tests into the test folder so that they're not like doing like really crazy stateful shit, in the same thing. So and that's a nice approach, right? But yeah, so a nice thing about Rust, and I'm gonna sort of go back to the slides and then wrap up, is that you can. It has semi-object semantics like I showed you, and similar syntactically, but there's no inheritance, which is really good because inheritance breaks encapsulation. And when you look at, I don't know, Python or Java or one of these other languages, they like inheritance is the way to get things done, and you're just leaking details all over the place. So it shouldn't shock you that something that has really good grained pub, it defaults to private. You can have pub, you can have pub crate, right? It shouldn't shock you that those things, exist and people are paying really close attention to that, in terms of modularity and how those things are structured. So Rust does have a trait system, which is a way, it's different from Scala's trait system in a much better way. So it lets you sort of stack implementations on top of things. And by the way, I love this. Sorry, I love this feature. Anyone else has used Rust, Alex, I think you were talking about it. You can have the compiler automatically derive certain traits for you, which is really nice. So it'll automatically, like, if it knows how to, like, as long as all of its fields implement debug, the compiler can implement debug for you. This is a procedural macro. They're called derived macros, and they let you do that to the point where the serialization library, if you take a struct and you mark it serde as the generic serialization thing, you can say you mark it deserialize and serialize. You can then, you want to crap it out to toml, you just use the toml to string function. You want to crap it out to JSON or CBOR, or there are a million things that there's rusty object notation. Like, there's some goofy stuff out there, right? Like, you can do that and you just sort of swap that out. And it makes it really easy because it's sort of, you have custom encoders and deserializers and things like that, which then also give you the opportunity to say, hey, I got invalid data because this parse is fallible. This parse didn't work, right? What should I do?
Yeah.
Right. And if those are recoverable errors, great. You can, log a message and drop the thread or whatever it's going to be. Yeah. So, let's just wrap up here. Yeah. So, woo. Okay. We talked about a lot. I know that because I put a slide in there that said, woo. And we now stop for your questions. Please let me know what questions you have. I know we said we'd keep this to an hour. Please, Alex, please.
Yeah, I'm curious if you've had any experience using Rustler and how expensive that might be.
Okay. I have not. I will tell you, I have not personally. I have used Rust to produce core libraries, which are then exposed to multiple languages with Python bindings and TypeScript bindings. I have not had the opportunity to use Rustler in life. I've messed around with it. There was a great article recently about how you can sort of use Rust to safely handle state. They made a graph database wrapper around a Rust graph database crate. And they exposed that to Elixir, which is cool because now Elixir has a native implement. I mean, you put it on, you're done. It will shock you how many Python libraries are actually written in Rust and no one knows. Like or.json is a great example. It can deserialize and serialize to JSON much faster, dates and data classes and all these things. It happens to be written in Rust and no one has to care, right? Because it has good cross compilation. Same thing with JavaScript and TypeScript libraries. Rust compiles to WebAssembly. I know people who have done, I don't know why, but I mean, the frameworks are getting better, but they've done like entire, front end interactivity stuff with Rust and compiled it to WebAssembly. We're now at the point where if you have a graphics heavy or processing heavy thing, you can write it in the right language. And if you want to ship it in the browser, it goes at near native speed. Like, no wonder Apple's scared, right? Like, they're scared that the web's going to eat which is, yeah, right? So yeah. And by the way, I just wanted to say, please keep in touch. I love this stuff. Here's me on Mastodon. But yeah, I mean, what other questions do you have? I'm really interested in your thoughts about how this is going, because the core point is, yeah, Rust is worth looking at for Elixir folks.
Yeah, there's one thing that you didn't touch on that, like, yeah, I'm gonna give you what you wanted, because we started this talking about functional programming, and you gave us two definitions, and like a lot of people do say like, oh, Rust is functional or something like that, and so you gave us two definitions, and one is absolutely like not applicable here because Rust is very much mutable data, allows mutability. And the other one, like, Rust does have higher order functions, like functions as entities.
As values, yeah.
But in kind of a weird way, no? Because because when I first read, oh, traits are this. Traits are what are traits? Traits are like abstract classes or something like that, right? Like class objects in Haskell, something like that. but then it says like, oh, and by the way, function objects are traits. And I was like, wait, what? What
Right.
does that even mean?
Okay, so let me show you. We're just gonna say that here we'll do returns return self where f implements fn. We'll do fn once, and it takes a vec of u8 and returns a. Can I do this? Vec of u8, right? Is that valid? No, there's a problem with this. Let me find out why. Syntax error expected. Bang! Right? Oh, here. No. In this case, I can just do. Sorry, I can get rid of the where. I can actually do this. Sorry, the generic syntax is not always interesting for me, right? Can I do this? No, because it expects a bang. So, yeah. All right. Anyway, you can basically, there are these traits that are there that are, I don't know what I'm doing wrong here, but that's okay. There are traits that are FN, which is for any closure. There's FN once, which is a closure that you can only execute once. And then there's FN mute, which is a function that, which is a closure that has mutability semantics and certain things there. Okay.
Yeah.
So, a great example of this is actually, here, I'll get rid of this and I'll just do one here. We'll do, I don't know, we'll do pub to here. We'll do contents to string, right? And this will return a vec of string, right? And so, the reason I'm returning a vector of strings is because I'm making it up, just so we're clear. Okay. So there are traits that are kind of like protocols. So the enum protocol in Elixir is roughly equivalent to the iterator trait and the into iterator traits in Rust, where if any collection implements those traits, then you get all the iterator stuff for free, just like in enum. So they're not linguistically equivalent because they have very different semantics with dynamic dispatch and everything, but they're sort of on the same conceptual wavelength there. So that's why I'm putting them next to each other, right? Yeah. So in that case, you can do self, contents, right? You want to do iter, right? So then you can do map, right? Byte. You can do byte dot to string, right? Okay. And then you can collect it into what you need to collect it into. Now, in this case, it's nice because the type, this is straightforward enough that you can do, it'll do type annotation. Other times you have to tell the function what you want to type it into using this thing called, and I'm not kidding, this is called the turbo fish. So you know how in like Ruby, the hash association arrow that's equals and then greater than is called the hash rocket, right? Like this is called the turbo fish because apparently someone saw it and was like, aha, let's do it. So here, I'll tell it, I want it to be a vec of whatever type and it'll infer it, or I can actually say, hey, I want it to be string and it'll do it. But because this is straightforward enough, I don't actually need to do that, right? So, but notice something interesting here. Is this, what type is this byte, right? It's byte of type borrowed U8, right? And it just so happens that, yeah, we are not exhausting, right? We are not using it up. Like contents to string doesn't consume it. But let's just say I did want to consume it and I went into iter, right? Now I get, so that basically consumes it and the byte here changes to U8, right? So why is that the case, right? Cannot move. Remember we talked about moving and having one owner. Cannot move out of self.contents, which is behind a shared reference, right? Move occurs because self.contents has type vec8, which does not implement copy, right? So in that case, we can do it. We can do into iter if we really want to use it up, but then we have to basically take away the reference and we're actually consuming the data chunk. So when you do data chunk.contents to string in this case, you're actually using it up and you're returning a vector of strings instead of whatever, which is why we didn't do that. And we just kept it as iter, knowing full well that does that. Now, there are great things you can do here. Oh, sorry. wrong side of the fence, right? There are lots of, you can chain maps, which are really nice. You can do, map, filter, partition, like look, the iterator trait has such nice combinators, right? For doing things, that's where you are. So yeah, you can return functions. You can even have functions as fields and structs if you're careful. Obviously you have to add a layer of indirection so that the compiler can size it properly. Yeah, I mean, there are really cool things you can do. You have trade objects with dyn. I mean, there's some wonderful work being done here. And we didn't even get into async Rust, which is its whole other kettle of fish. Yeah, Pedro, does that give you a little bit? Does that like take the edge off your hunger a little bit?
Yeah, a little bit. I still find it kind of weird how like it defines functions as like abstract classes, like in Haskell terms, but
yeah, yeah, it's
like,
different though. Go ahead. Yeah.
Okay, let me be precise. As what's the name of this again? As traits.
They're traits, right?
But like, yeah, it does demonstrate the connection between that trait and the closure that you are using. You have to be using a closure that fits that trait.
It has to be typed. Correct. Yeah, that is totally correct. The compiler is checking your work for you to stop you from.
Okay.
And
so
again,
if you would
go ahead, please.
If you would use a function that does not fit that, like it would be applicable to a different trait, then it would not compile.
Yeah, it would not compile, and there are 3 function traits that you can use to sort of do that. By the way, just so you know, the iterator trait is equivalent to the enum in terms of, you just have to, the required method is you have to implement next. And if you implement next, you're good, right? You sort of get the rest for free. That's kind of like Scala's traversable trait. It used to be. Ruby has the enumerable mix-in. There's Elixir's the enum protocol. It's sort of along those lines, which are really nice. I'll tell you, Pedro, the truth is that the most fun I've had with combinators and Rust are actually error handling and option handling, where you can basically map over an error or map only, like you can map over a value if it's okay. It's beautiful what you can do. Like you can do some really beautiful things with those combinators. And I find them much more provocative and useful, or, useful because the error handling is so nice, than I find even the iterator stuff, which is obviously much more prosaic. But the truth is that I produce errors at a higher rate than I produce, good pipeline transformations. So, which I assume is the case for most people, but yeah. So like, I would definitely look at result. I would look at result. Here. So I would look at result, and it does. Here you can do, there's map error, map or else, right? Like they're beautiful things you can do. It's just, because it actually implements from iterator. There's a whole type conversion system where if you implement a one-way conversion, the compiler will automatically implement the other conversion. So you can just do things like into, and the compiler will be like, oh yeah, you're passing this value into a function that takes a vector of bytes, and you provided the conversion from your type into a vector of bytes. Therefore, I know how to do that, and the compiler sort of fills it in for you. And that gets into, things like one of the reasons that Rust binaries are big for not having a runtime is because they use code monomorphization, which ties into the whole trait system and the type checking thing. Listen, the Rust compiler is slow, and it could absolutely be faster, but I'm willing to live with it because it does so much to save me from myself. I mean, we have to be honest about, shit happens, right? Like it should be easier. And honestly, it should be easier. So yeah, but
trade-offs, trade-offs.
It's all trades. I mean, Shiva might produce, bug-free code, God bless, but I'm not him, he's shaking his head no. Sorry. Sorry, brother. Sorry. Yeah.
I just have one question. How good do you think Rust standard library is? Because for example, Go has a very good standard library. Like almost always you don't have to import any external dependencies. And I've heard like good and bad things about Rust. Like some people feel that Rust standard library has just the things that you need, which is good. But some people feel like, hey, it could be a bit more extensible. So what are your thoughts on that?
So I will tell you, there are many times I have wished that the Rust standard library was more batteries included. Along the lines of, I mean, I have some issues with Go as linguistically, but in terms of functionality, it ships with a lot more out of the box.
Right.
So I think you're making a really good point. I've had very few. I mean, I do own a crate. Oh, hello, kitty. I do own a crate. Whoops, not Crate and Barrel. I hope that's not in my history. Now I'm gonna have very nice silverware. Much too nice for me here. So I do own the Test Anything crate, and this is one of the few that has no dependencies, right? Like rarely do you see that. Right. So I'm just being, I'm just being honest, that like, yeah, so this is my crate, right? And it just so happens that it has no dependencies. Maybe I should throw in some dependencies. I mean, but like most of the time, I mean, this is just manipulating text, which is a fair amount of our work, and it can do that very impressively. They're wonderful CSV libraries. You don't have to do, split on comma and hope for quotes, right? Like, they're really good libraries. There's a really good ecosystem out there, but it does ship without batteries included, Shiva. You're right. You're right.
I've been struggling to learn lifetimes. I'm just stuck there. It's just like such a big cognitive load. And I'm like, I keep hearing good things. People try to refer that as like good cognitive load. So I'm like, okay. So yeah, trying to push it through.
Shiva, I'll tell you what. There's a site, I don't know, I just learned about it. There's a site called is it Rustlings? Rustlings is like a little small exercises, right? But like seriously, reach out to me, man. Right? Like, I mean, so that the spam bots don't pick it up. I'm Yankeltron@gmail.com. Like, please reach out, right? Like, I'd be curious to know where your hangups are, if only so that we can then work on better educational material and people will, because your mind works a certain way and we should pay attention to that. That's, I don't know. I hope that's not heretical, right? Everyone's different. So yeah.
Good. Cool. I appreciate it.
Please.
Yeah, I cringe every time the compiler tells me I need to declare a lifetime. It's like, oh my God.
Yeah. So the truth, yeah, and that's a good point. Most of the time, I mean, with every binding, there is a lifetime, right? It's just most of the time it's implicit, or it can be elided, right? You don't have to specify it, but occasionally you do, and then you're like, what am I doing? It always feels a little bit like black magic, even though I like understand the theory behind it. I always feel like I'm like I might as well just use unsafe, right? Like, I just screw it. I'm so, but no, it usually ends up working out.
What do you do? Like, you just trust the higher powers? Is that what you're saying? Like, yeah, if you're saying that's the way, then I'll just believe you.
So to a degree, but that's only because the Rust compiler's the error messages are so good. It's like, hey, you can't do what you're doing, but I think you could try this. And then you try it and you're like, huh, that worked. Why? And then you spend 15 minutes reading it and you're like, oh, well, now I know not to do that again. All right, cool. That's nice. There's also a really good linter that comes by default. It's called Clippy. Cargo Clippy gives you stuff, but you can also do Cargo Clippy -- fix, and it'll like fix most of the things you have, right? So like here, this says it has a public len method, but no is empty method, which is idiomatic for Rust. So we could do that, right? Unused code. I mean, all the stuff you would expect, but I'll tell you, the error messages are really good. And then you can always do, for further information, you can just click on the link, and it gives you all the Clippy links, and it tells you what to do, right? So yeah, I mean, it's pretty nice, So yeah, sometimes I do end up trusting the higher power because the Rust compiler tells me exactly what to do, and I try to do it and see if it works, right? But at some point you get to understand why, and then you're okay. It's all right. But yeah, it is a mindset shift. I will tell you that, Shiva, the one thing I would say is that I find that the mindset shift from imperative, mutability, mutable state, etc., to a more functional mindset is the much bigger hurdle than the safety and correctness semantics that the Rust compiler lets you rely on. Personally, I found people have a much harder time transitioning to one than the other, which is again why I'm so curious about your experience, because they're so
I hope it just becomes it doesn't stay like that forever.
It doesn't. I thought it would. I mean, there was just full disclosure, and then I know, Mike, we got to go, and thank you all for coming. But I'll tell you that there were a couple years where I was like, Rust isn't worth it. The guardrails are too high. And they fixed a lot of stuff, and now it's one of the tools in my toolbox, right? I mean, I can easily tell you 3 things I hate about Rust. Listen, you should be able to tell you, if I ask you what's your favorite programming language, you should easily be able to tell me 3 things you love and hate about it in no time flat. If you know your tool, you know to love it and you know to hate it. I can tell you 3 things, but Rust is one of the tools in the toolbox that has become very valuable for me over time.
I also think the language server is really strong compared to others. Yeah, they've done a really good job. Rust Analyzer is just wow.
It's so good. Yeah. It actually, this is what's giving it all the ability to do type annotations and stuff like that. Like these are added. So you can double click it and it'll put it in the actual text, but this is all from inference that the editor tooling is giving you, and it gives it that in every editor, Emacs, Vim, whatever you want. So it's pretty impressive. Yeah. All right. Mike, is it okay if we call it? I mean, I feel like there's some good
absolutely
news, but, all right.
Yeah, for sure.
Thank you so much, and I mean it. Please keep in touch, right? I really love this stuff, and I would love to hear about what you're doing. So please, thank you.
Good stuff. Yeah, perfect. Thank you very much for that. That was awesome. And as always, I'll put the YouTube video on the meetup group. If anyone thinks they've missed something or want to go back to it, you'll be able to by this time tomorrow.
Marvelous. All right.
Awesome. Cheers, Jonathan.
Thank you so much for having
me.
Take care.
Thank you, Mike.
Thanks, guys.
Thank you.
Thanks, everyone. See ya.
Bye.
Thank
Bye.
you.